Hello. In this lecture, we will understand in more details what are informational messages. Informational messages can be sent by either of the initiator or responder after the Diffie-Hellman keys has been shared. The information messages are identified in the IKE header to have an exchange type value of 37. This indicates to the recipient that this is an informational message. Now, the informational message could be either a notify or delete. Notify has a payload 41 and delete value of 42. If it's a notify message, this means it can be either an error message or a status message. So, all notify messages are identified by the payload value of 41. As the peer gets this notify message and sees the payload value of 41, it knows that this is a notify message. It will then pass this payload. As it passes the payload, it reads the value of the notify message type field. Notify error messages are in the lower range of values. If you see here, they are valued 0 through 46. So, if the IKE peer receives an informational notify message with a message type of 46 or less, that means this is a notify error messages. Now, the error messages are listed here. It is notable to understand that the payload header contains an indication of what is the next payload in the packet. This is the mechanism by which IKE parses the bits and pieces of the IKE messages. So, if we are looking at the IKE packet, we would see first that the exchange type is 37. Now, the stack would look at the next payload to know whether this is a notify or delete. If the next payload is 41, that means it's a notify message. If it's a notify message type of a value of 46 or less, then this is an error message. Now, the error message has a type that indicates what is the error. If the type is 1, for example, that means the message is unsupported critical payload. So, side topic here. The critical flag can be set by the initiator or responder to let the other party know that it will have to understand this payload type. That means this payload is mandatory. If the recipient doesn't know how to interpret this payload, it should end the conversation. Now another important error message to know right away, an invalid IKE SPI. So, this happens if the VPN device gets an IKE message with an IKE SPI that it doesn't know about. In this case, what happens is the recipient will have to be able to read this message. So, this error message is not encrypted, and the reason why it's not encrypted is so that the other side can read the message. Now, the RFC dictates that a VPN device getting an invalid IKE SPI should not respond. Okay, one reason the RFC designed it this way is to avoid becoming a participant in a denial of service attack. If the VPN gateway receives this message from an imposter, with a spoofed source, and it does respond to it, it would be used by hackers for denial of service attack. Okay, going back to our topic, so we have here a list of those error messages. Notably, one famous one is no proposal chosen. This lets the other party know that the security association requested, meaning what encryption, hashing, integrity, and Diffie-Hellman types that was requested by the peer, is not supported. If you see this error message, you should know right away that this means the configured transform sets are not supported by the other side. Another one that should be well known is authentication failed. If you see this notification message type, that means the pre-shared key is not matching or the other side couldn't validate the auth payload. Now, if the notification message type is higher than 16,000, this is a status notify message. There is a lot of them here according to the RFC. Now, one thing to be aware of is that informational messages of type notify with a status has to be protected. Meaning that they occur after both sides calculated the Diffie-Hellman master key and the security keys. When the initiator and responder gets this message, it is authenticated and encrypted. If you are analyzing a packet capture, you would see that it is encrypted. Okay, so some of the messages, the status messages that we need to be familiar with is the initial contact. The initial contact relays the state of the exchange. So, when the initiator sends a notification of initial contact, this lets the other party know that this is the only security association that exists for that peer. In the event that the recipient has an existing IKEv2 from the same source, this means that this information is stale. So, this would cause the responder to delete the stale session. Also, since we are discussing this topic, another use of the informational messages is to achieve dead peer detection. The way IKEv2 does dead peer detection is by sending an informational message with an empty payload to identify if the peer is alive. If the peer responds to that message, this will mean that the peer is alive. Hopefully you enjoyed this lecture. We will uncover more topics in the next lecture.